It was always like, get my comfort lunch. I really want to go to see that one. I know whatever I need to know from me.
Hi everybody.
Hello.
Java,
But if you're moving more towards Spark, then you're probably going to do more Scala type of Scala work. But Python is really like leading rank of a lot of it's not efficient for anything, but it's universal and fairly accepted. So lots of different projects.
I have the Darker Soul, so I've got the line right now. Right at it.
You would never guess
They're
that.
using
Very important
integration platforms. A lot of people like using Python for things. Python is using like heavily data science work, and therefore data so you integrate with
And more beer, we rant about to do. And data engineering and data
Spark,
science.
your first class language for Spark is going to be Scala. The second one is Python. Because
Bradford
doing
It's famously not here.
I do a lot of Python work, but there's more efficient ways.
They expect a lot more time to drink beer.
Like the
And I'll have
result
a belligerent question.
isn't going to be at maximum efficiency, but that's not necessarily a bad
Okay,
thing.
no one's showing up till 7.
Because the scalability.
We have 2 Google tools.
Coffee?
Oh yeah, live
Okay.
streaming all over the world.
Question for you. So here's what I just had happen. I launched a bunch of steps, right? And I changed my key type to the C38X.
I need to have those antlers for the scalability show. Hi, I'm part of your scalability show.
We have a very, very nice lady here, part of the Scalability Show, live from Seattle.
Thank you. I'm here to listen to the geniuses.
We are those things. We prove it by wearing antlers.
Look, the antlers. We have many, many, many in the crowd. Look at all of them. We're talking to geniuses. Come, bring your antlers to the show. Quick.
Where's the cocaine?
Here's another couple genius antlers.
Why are you bringing me back?
Right there. Look how cute you are. I want a pair. Where's mine? All right, where is the schnapps for my coffee? Oh, Microsoft guy?
No, Google.
Looks like their colors, doesn't it? Shame on you. Shame on you.
Purloined by Google.
Oh, did they?
Google actually added the red and the yellow. Microsoft only had the blue.
Oh,
This
I'm
is the
wondering.
Microsoft guy where you would only see like a little piece of it.
I'm wondering who stole the colors from who, because you guys are looking a lot similar these days. What's the DG for? Damn Google? Goddamn Google?
Something like that.
I want to know.
It could also be the Google development.
Oh, right. Yeah. Where I come from.
There's a mini
I'm sorry, right? I love you guys. You know what? You know what I mean? Are you Google too?
I'm not.
One thing you can say about Google is that all
But no, I mean,
work, right? I don't care what you use, it works. And it doesn't break. Keep up the good work over there.
Thank you.
So hi everybody. So we have Jana and Evan here. So they are the infamous, no, famous, has to be sponsors with Greythorn, the scalability meetup. They're very, very important because when you're doing scalability stuff, you have to have beer.
We did have to just clarify that we don't actually make the beer or pour it ourselves. We just pay for it. So we are more than happy to do that afterwards.
That is also very, very important.
That's great.
So we're having a walk through Zulily here. Let's see what, oh, this looks pretty nice. And of course, guess who's at the beer table?
I love that. Oh, I love that. Oh, wait, don't move. Can you do that one more time? Put it in the back. That's a great photo.
I think I'll have one of these.
But, you know, I mean, right now, I'm still I don't know. That's really hard to say. Right now, we're like, you know, the best person to cattle, you know, like, servers or cattle, you know, they're not healthy, they want back and shoot them, you know, and like, wow, you know, like, and beyond that, binary code. How about now?
Okay, so I'm turning the mic test. Now you can hear yourself.
Check 1, 2.
Hello? Hello? Check 1, 2.
Needs to be a little louder.
Hello? Check 1, 2.
Louder.
Loud? How do I make it louder? Which one is mine? Go ahead. Hi, this is Brandon. Hi, this is Brandon. Hi, this is Brandon. Check 1, 2, 3. I see you up here. Maybe your volume needs to go up in your ear. How's that?
This is good.
This is good. Okay. Let's put the volume control. So it's online.
I'm just going to leave it soon now.
Yeah.
Okay, I must have it.
Oh, yes. I'm going to start announcing. Get your shit together.
I'm ready.
Slow ass bitch.
Where's our shit? Speaker has to be wearing these, okay?
I'm so hopped up on paint meds.
How do I use this?
Just put it around
Wait. Oh, around the neck? Then what? Yeah? I hear nothing.
You won't hear anything.
Tra-la-la-la-la-la-la-la-la, tra-la-la-la-la. Ya-la-la-la-la-la-la-la-la, ya-ha-ha-ha. Tra-la-la-la-la-la-la-la-la, tra-ha-ha-ha.
It's on a delay.
Sound check. Sound check. It's scalability. Sound check.
Tra-la-la-la-la-la-la-la-la, ya-ha-ha-ha, 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 ya-ha-ha-ha.
Wow.
La 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 la.
Where do I plug in my slides?
I don't know. Check your ass. I'm trying to get this going so we can rip before we get going so we don't have to have an intermission.
Cool.
Where's the IT person? Where's Julie? How do I turn the mic on? Where are the bears? Isn't that the greatest name? I do have a bucket named Badger Bear. Did you see the lambdas running?
I did not.
We are actually pushing data.
Last night, so I woke up at 4 o'clock today.
I went to bed at 4. And I slept 4 hours.
The good thing is that on their
Tra-la-la-la-la. Tra-la-la-la-la-la-la.
For what? What is he saying for?
What? What?
yes. Sure. Perfect.
Tra-la-la-la-la-la-la-la-la.
Oh, Nick, this is Jeremy. You guys gotta hang out.
Ah, nice to meet
He
you.
just moved here from San Francisco. Nick was like college roommate.
Tra-la-la-la-la.
Can anyone hear me? Oh, there you go. All right. One should be good.
One what?
You want this? You want this?
I'll take the mic thing.
Can you get this working?
This one.
Yeah.
That works already.
No idea what that is.
Tra-la-la.
Which one
You
works?
get this. Wait, let's try the black one. That one's charging. All right.
Ladies and gentlemen, boys and girls, welcome to Seattle Scalability December, hosted by Zulily.
We're going to get started in a few minutes. This is a very special occasion with all three of the organizers here. So if you have any problems,
I've always wanted to feel special. Thank you.
You can always flog us afterwards. He takes pain very well. Clive does not.
I'm a developer.
So everyone, thank you all for coming. We have a couple of fantastic speakers tonight. Bradford speaking about whatever he does in his spare time, and Zulily speaking about Kubernetes, which is, you should all call it Kubernetes just to make Google angry and to make Greeks happy. Otherwise, if you really want to be funny, you can call it Kubernetes or something, which is just about as good as Kubernetes. Anyway, welcome. Afterwards, Greythorn is hosting beers at Patty Coins, which is around the corner. So can I get a show of hands for everyone who may be going for beer? Come on, it's free beer.
USA.
B-E-A-R, beer, beer, beer.
There we go. All right.
All right, we got 11 here. All right, so are you ready yet?
I've been ready. I just need to know where to plug in my computer. Yeah. How do I make the slides happen?
Could someone please explain our IT professional here how to plug a computer into a into a computer thing? Yeah, there are cords.
You want to connect it to the machine?
The what? Yes. Yes.
Yeah.
Is this your incentive to get me to go faster? Close enough. Yeah, it's a little cut off, but you know, such is life. Thank you. Hi everybody. Thank you so much. And I did the counting. I think we're getting really close to like our 100 or so meetups. So I'd like everybody to give yourself a round of applause for making this one of the largest tech meetups in Seattle that's still around and somewhat organized. Really appreciate it. We've come a really long way since we were illegally talking our way into meeting rooms at UW, which, although fun, was not scalable like so many things I've built. Anyway, so this talk is all about scaling for cool teams. We're not teaching the cool teams how to scale. We just built something scalable that they use. I've done a lot of things at the time. I've been a software engineer for almost, I've been writing code for 20 years. Professionally been doing it for 10, and confidently for 2. Although every time I learn a new language, I feel really more incompetent. For this, you may have seen my talk. I ran a distributed database company called Drawn to Scale. We built one of the first completely distributed SQL databases. And then quickly discovered that Google had done the same thing way better 5 years before us. So this time I decided to use their stuff instead of build mine. And big thanks to Zulily and all of our other sponsors who helped us throughout the year, including my company, 22 Acacia. 22 Acacia folks, raise your hand. Got me, got Nick, Pat, where you're at, cool. We are also hiring, so if you're into building distributed systems, data strategy, really doing anything with data, and you know enough about Java to be really angry about it, or any other functional programming language, we would love to talk to you. So before I give the real story, a quick pitch about 22 Acacia. We basically do data science, strategy, and engineering. We like to work with companies who actually make money. So this includes many companies in San Francisco. And we go in, we help you figure out what your biggest problems are that are keeping you making money. And then we write software that helps you make more money. So we're about helping you generate revenue and building data products, not just making pretty dashboards in this league. So we're all about end-to-end engineering, all about building data strategy. We've got customers in everything from pharmaceuticals, digital learning, travel. And to give an example of how effective we can be with optimistic projections, this one project, one of our larger customers, is going to add $4.6 million to their top line revenue. So we would love to help you do that as well. And for Google Cloud Service Partner and AWS is coming along with that as well. So we want to help you grab X, hat, or eyes. You want to do scaling and money and all that fun stuff. So Cloth is a social network for fashion. Raise your hand if you've seen Clueless. Alicia Silverstone. Yeah, fabulous. Not bad for a group of engineers. So one of my co-founders, Ray, who was in the fashion industry, was watching Clueless one day and saw the closet scene. And you remember closet scene, the song, "Gonna Be a Supermodel," is playing. And there's a computer in the closet, and Alicia Silverstone's blondness visage is on the computer. And there's outfits rotating that say, hey, what do you want to wear today? And it's got a listing of everything in her computer, and then it chooses her outfit. My co-founder said, I want that, because I can't keep track of all of my outfits. This is why it's really important to have a co-founder that is not a white dude for any company you start, by the way. Also, it helps to have investors that aren't white dudes. So, we help you organize your wardrobe and keep track of your outfit. By the way, what is the URL for this? I didn't get to tweet it.
It's on Twitter right now. SeaScale. Look at the the tag SeaScale, and there's a live stream.
Cool. Please pause for 10 seconds while I build my ego. Hashtag SeaScale. You can tweet about how much you love hashtag SeaScale while I'm tweeting about this stream. Okay, how does Twitter work? Tweets with SeaScale. Say again. Oh, yeah, that's much better. All right. Retweet, 2 followers. Post to Facebook. And it's really important to have engaging hashtag content. Yes, I'm using the Tinders like the cool kids. I'm swiping right on scalability. So, Cloth helps you organize your wardrobe. Day in the life of the average Cloth user. Wake up in the morning, you find some super fire, super fly outfit, take a selfie, categorize your clothes, say, this is a nighttime outfit. It automatically detects the weather. You can tag your outfits and you store it in your wardrobe to search for later. Then, when you're looking for some inspiration next day, you wake up and you say, it automatically detects the weather, applies a filter, and say, I'm in a mood for something kind of summery, searches through your tags, recommends some stuff for you to wear. When you wake up in the morning, it detects what the temperature is and what the weather is going to be, and suggests a few looks in your alarm clock. Yes, thank you for everybody that's applauding. That wasn't my idea. Again, really important to have a female co-founder. Detects some outfits for you to wear. And it even will do things like, hey, you've worn this outfit a lot, it's one of your favorites, let me recommend that. And this outfit you actually haven't worn in a while. And go on. One of our releases that come out soon is also going to have a recommendation engine to recommend cool accessories to go with your outfits, to turn old outfits into new ones. And you can search in real time and see what anybody across the world is wearing for more inspiration. So you can download it at clothapp.com. I guess I have to have this thing really close to my face. So our first version of Cloth came out a couple years ago, and it was totally not social. It was basically just a way to look at your wardrobe, and that alone had 300,000 users. So I'm like, this thing is hideous and has a ton of users. I want to make it good. That's when I joined the company. And our goal was to reach 1 million users on week 1. And we went and raised some angel money to do that in June of 2014. And given our budget and timeline, we basically had to launch at the end of October. And the resources we had is one quasi-sentient backend engineer. That's me. And this is kind of the path of technology. It took, I believe, 5 engineers to build Instagram, and I guess it took them about a year. And I had 1 engineer, 3 months, and basically no money. So, wanted to support 1 million users, and I've built a lot of distributed systems in my time, and I had a few fundamental principles I wanted to try to stick to, which is the reason why we ended up building this on Google Cloud Platform. First thing is no servers. So no EC2 instances, no GC2 instances. Every component, everything you run on a server, you basically have to keep alive. And that, in my experiences, basically increases the risk of failure of that component by 10x. I just don't want to build like high availability things and monitoring and all that horrible stuff. So I said, all right, this is going to be a stateless app. Can't be on any server. Next thing is no SQL. And I can't tell you what now that doesn't mean no SQL, but I can't tell you what a joy that is in my life, having built a SQL database from scratch to commit to the zero SQL lifestyle. And here's the thing is that if you're building an app, you really don't need SQL because you should be using your database as basically a filtered index key value store because you don't need to do like joins and all that stuff to present data. You don't need that advanced analytical stuff. And plus, scaling SQL was the bane of my life for a decade, and I never wanted to have to deal with that again. By the way, all these general principles basically came from years of agony in programming. So it had to be built and maintainable by one person. What that means is I need to be able to keep the entire system architecture in my head. And there can't be ops. And I have another presentation you can check out on LinkedIn about ways to basically, this is sort of pre-DevOps and ways to manage distributed systems. And the key problem with having a system that needs hands-on ops is that you can only scale according to your budget. So if I had something with a lot of servers that needs to be monitored, I'm going to have to hire ops people to keep it alive, and that's not going to scale. And it has to be, every component has to be asynchronous. Oh, I see this is very directional. Every component needed to be asynchronous. It's a mobile app. Mobile users have the attention span of a gnat on meth. So if anything took more than like 200 milliseconds, we were hosed. And finally, it didn't have to be Java, but I didn't want it to be Node. I needed a real programming language, and so it was great to have a platform that supported that. I'm allowed to say these things. So the way I went around this is I said, we're ripping off Instagram. Let me look through every presentation Instagram and Twitter have made and figure out the modern analogs to their components. There is no shame. We all know that great artists steal, and I am nothing if not an artist of code. So basic thing is we have an API, or we have an app ecosystem around that. Not really going to talk about that tonight. A series of administrative tools, and the important part are mobile apps. Behind the API, we basically have several services. They're not really microservices, because who cares? Threw it on a giant code base anyway. And a few things. Wardrobe or output store, we have a service for maintaining that. Distribution, which is about taking in data, pushing out data. Search, and behind it all is our social graph. So here is the main path we take through the code base when you do basically adding an item to your wardrobe and then sharing it with your friends. We have API by cloud endpoints, and I'm going to go walk through all these architectural decisions. Backend app servers written in Java, powered by App Engine. Anything really small updates are just done synchronously when you make your request, so like changing your name or so on. And then anything requiring more than 100 milliseconds of latency is pushed off to task queues, which are asynchronous workers. So that's like timelines and fan outs, building search indexes, manipulating images like changing PNGs to JPGs and other things, building analytics, and it's all basically backed by either cloud search or cloud data store. So walking through the diagram, API endpoints are pretty cool. If you've ever used things like JaxWS or Jersey, very similar to that, where you annotate your method, and this blew my mind because this was actually the first API I'd ever written. I'd mostly just done like super low-level systems code in my life. So you basically name things like the request query and the parameter, and then you create objects, because if you don't have an object in Java, you have nothing. And those objects contain the request bodies. So, you know, user profile object just has an ID, a first name, a last name, so on. And then Google API endpoint, cloud endpoint. I forget everything Google does has cloud in front of it. Google Cloud endpoint takes that request, does some magic to it, you know, turns the JSON into Java objects and all that good stuff. So it's really straightforward, and that's why I chose it, because the last thing I want to do is manually turn strings into objects and all that terrible stuff. Another kind of cool thing about it is the Google API endpoint is self-documenting and self-interactive. So you make this method, and then you go to a URL on your server, and it publishes an interactive API that you can play with, create objects, and all that. It's kind of cool. And I secured it all with OAuth and Auth0, which is super magic. What a cool company, and they're here in Seattle. Basically, it allowed me like 2 or 3 days to connect, you know, people's Twitters, Facebooks, do emails, password protection, generate tokens, all that cool stuff. So that was a really helpful big accelerant for us. But there's a few problems with API endpoints. And I'm going to go over a list of suggestions to my current Google friends who are here, if your managers haven't already heard this. It's kind of outdated, and that you still have to manually build objects in the actual cool documentation tool, which is a real pain. It's not so good at type inference. The documentation can be kind of a pain to generate. And the super cool magic thing that they promised that didn't actually work is that you would generate, build a REST API, and then it would generate Objective-C and Java Android files that basically talk to that API that you could just install on the client. That turned out to be an absolute mess. And I think our API has like 20 methods, and that code generation tool took 30 minutes to run and generated something like 270 header files. And hundreds of classes. It was an eldritch abomination. But I hear they're fixing that in a super cool new version coming out sometime. So App Engine I think was the first cloud component that Google ever released. And I call it the magic auto-scaling server thing, because you basically build your app with a REST API, and it takes care of deployment, updates, scaling, brings up new instances according to latency, and it's really fast. It can bring up new instances in seconds. On your local machine, you can start up a test server in milliseconds. It makes closing that whole dev test loop really fast. And it does some really neat stuff, like you can say, I want to split my traffic between these different groups of APIs and so on, so I can do red-green testing. I can do gradual deployment, so I can see if a new item poisons the rest of the servers and so on. But it hasn't been updated in a while. It's still on Jetty 6, which is no bueno. You know, I think Jetty 6 was written in the Reagan administration. Not exactly sure. And they have this new thing called managed VMs, which is very cool in theory, but it's basically a really thin shim on top of Docker. And it's pretty new, and it takes minutes to deploy a managed VM on your local machine, so it kind of takes forever to test. There's a lot of cool stuff. So you can have a new Jetty, you can have an up-to-date version of everything, but it's just sort of hosted Docker, and you lose a lot of the App Engine magic. So we stuck with the old App Engine. You talk to the API. API is powered by App Engine instances, and then all the asynchronous work is done by task queues, which are basically also very lightweight App Engine instances that are push and pull workers. You can define how many workers per second and how many requests per second you want in a config file, and then the old way of doing it, you would basically just inherit or implement a Java interface, and everything had to be serializable in that implementation, and then it would just go off and do the tasks when you request it. So a lot of our bigger work is done by this. Doing the fan-out algorithm where when you post something, it posts to all your friends' timelines is done there. Any of the heavy lifting around building, restructuring things for analytics, so on is all done there. And now, the new version is really neat because instead of extending a Java interface, you just give it an endpoint to execute, like an API endpoint, and it calls that. So the most important reason why we chose the Google Cloud is because of the database. I've built too many distributed databases in my life to ever want to do it again. There's no Hadoop in here. There's no Mongo in here. No anything. Because databases are what kill your app scalability. You know, scaling just requests and servers is trivial, but you know, sharding SQL databases has always been horrible, and you shouldn't really trust anybody who says they can do it in real time. Google Cloud Data Store, which I'll go into some more aspects of, is really neat because it provides all the stuff like indexes, lightweight queries, object embedding that you need to build an app, but without any of the SQL nightmare. So this is the major objects we have. We have a user object, and within a user object is embedded things like that user's wardrobe, that user's profile, their timeline, all their check-ins. And these are physically embedded in the same, I'm going to call it table, not really a table, but the same table that contains users that are indexed by a user ID. This is where denormalization becomes really important. So a user wardrobe, you load a user, you get their entire wardrobe. Cool, 2 requests, no joins. A wardrobe consists of wardrobe items. So, you know, color, tag, category, all that stuff. And then when we write a user wardrobe, within the same transaction, we write to another table called wardrobe items. So user wardrobes are all wardrobe items per user. We denormalize that, flip it around like a reverse index, and then we have a table called wardrobe items, which is just this huge, tall table of things that are indexed by the wardrobe item ID and the user ID, so that when you're scrolling through your timeline, those items in the wardrobe are loaded immediately by a key instead of having to figure out, all right, well, this is this user's profile, let's load their entire wardrobe, and so on. So the most important thing when you're building your app database is every query needs to be a key value query. Everything should be retrieved by preferably a long index ID. So Cloud Data Store is my favorite. It saved me so much time. It probably cut off 6 months from our development cycle. And the most important thing to keep in mind when you're building something for Cloud Data Store is you need to write data how it's read, because writes are super cheap. Your data volume, you know, is not that high on writes. If you're a consumer app, 99% of your load is going to be read. So it's fine if you have to write something 4 times, because that allows you to keep your access time you know, to milliseconds instead of having to do joins and other nightmarish things. So Cloud Data Store has schemas, it has transactions, and it's about basically storing typed objects and embedding those objects within each other, thus hard coding a relationship. And you can have lists and sizings and so on. And you know, the important thing is to normalize everything. And you can do joins in code, but you don't want to do joins in code. And we even use this for fan out instead of Reddit, which is not allowed in my lifestyle. Fan out, you know, it's sort of typically the most difficult thing to do at scale. So we did it the laziest way possible and just throw money at the problem. We have these task queues. So say you check in your item, and we're going to go append it to all 3,000 of your thirsty followers. So we have a task queue, every post that does. That task queue goes, loads a friend graph, says, all right, I need to go add this post ID to these people's 3,000 timeline. It goes and does that. It loads the list loads the timeline from every single one of those 3,000 people, appends it, trims it if it's too big, and then stores it back. Now, it sounds really horrible and tedious, but if you've got 3,000 followers, we spin up 30 queues within a millisecond or two, you know, append to 30 lists in there. It goes really fast because it's massively parallel. This won't scale to 100 million people, but that's never going to happen, so who cares? And then my favorite thing is Objectify, and I can't believe I'm saying this, but it's an ORM that actually works. That old quote, object relational mapping is the Vietnam of our industry, is absolutely true. I can't tell you the number of consulting gigs I've done where I've gone in, ripped out Hibernate, and replaced it with artisanal, handcrafted, local, organic SQL queries. But not this time, and I swore, no SQL anywhere. So there should be a code block in here, and it's not showing up for some reason. But maybe here? Yes, okay. So this is what it takes to store an object in the database. Objectify infers the type. You can annotate it with a few flags, and then you basically just have save and load methods that say this.save, this.id.load, and it goes in, creates an instance of everything, and then returns an object. It can do some really cool stuff like say, so we have a user, and within that user, we have a user profile, which has like 30 different fields. But the user profile is an embedded object, so I could put an @optional in front of it, and then only load that user profile on demand, which is very helpful. Now I just realized I haven't been standing in front of the camera at all. So, yeah, Objectify has basically made my database code 0 because objects come in through API endpoints, do businessy, logic-y things to those objects. The same objects are stored back in the database. So instead of writing database code 3 times, I write it 0 times, and I get to sleep and not take prescription medications to get through every day. So analytics is the other thing that's really important to have with your app. So after we've written things to Cloud Data Store, we stick it all in BigQuery tables. And BigQuery is super magic because unlike Redshift on Amazon, I call it scale-free. Everything at BigQuery, when you write to a BigQuery table, is stored across like tens of thousands of machines. So it's insanely parallel, and you don't have to care about keeping a cluster up or figuring out how many machines you need or expanding or shrinking your data. It just works. Really easy to load stuff from Cloud Data Store, and it's really fast. Now, it's high latency. It's going to take you a few seconds to get an answer. But whether you're crunching a gigabyte of data or a terabyte of data, it takes about the same amount of time because it's massively parallelized. So it's really magical to basically not have data warehousing nightmares anymore. The only thing that's kind of weird is that the billing, and I understand why they do this, is per terabyte processed per query. Now, that doesn't mean terabyte of raw data because they do a bunch of indexing and like other kind of magic things. But it's still kind of weird that that's how they bill you by it. but I'd much rather be billed by something like that than have to keep up a bunch of servers and bring them up and spin them down. And remember, it's append only, it's not for live data, so don't use it to power your app. Google Cloud Storage, or as we call it at 22 Acacia, GS3, is basically a slightly better S3. It's got a cool UX, and it's usually just an object store, but the really cool thing that's built on top of it is called Google Images Service, which, being a fashion app, means there's lots of images. They got to be processed. Like, I think every image is viewable 10 different sizes and resolutions and formats, like across different mobile clients, across the web, different browsers, thumbnails and search results, and so on. So you can basically do a bunch of stuff right in the request parameter. You can resize by using, I think it's the I parameter, so resize by the longest size. You can rotate, you can flip, you can do a whole bunch of really neat stuff. So an entire nightmarish chunk of highly synchronous code is non-existent because we don't have to deal with images. And that probably knocked off a few weeks of development time. And Stats Driver is very neat because it does a lot of the monitoring and alerting you would traditionally build into your app and use a bunch of third-party tools in one place. So, you know, when you spin up an app engine instance, I think there's like 30 or 40 different metrics that monitors for you, and you can define your own. Also handles alerting and all that, but we really didn't use this much because, for better or worse, we had no way to fix things if stuff went wrong. So if it wasn't a bug in our code, it was Google's fault. And there's nothing I can do but sit back and wait for Google to fix it. Luckily, nothing ever went wrong on that scale. But it's very cool to have this entire monitoring suite that just works right out of the box. Although a pro tip for life, I've also gone to a lot of companies and done up stuff for them. And they'll have like 40 different alerts that people get paged for. Like, we got 49 messages a second instead of 50 messages a second. And somebody's woken up at 2 a.m. So if you want to maintain positive relationships in your life, do not ping ops people for things that they can't fix. Thank you. Thank you, Jeremy. And the final thing, logs. I hate logs. I think logs are the worst. And if you're diagnosing problems by going through logs, sorry to my friends, by the way, who I think work at Paper Trail. Are you here? I hate logs because they should be your last resort of debugging. Your catch bugs, anything that's a bug in live data should show up in your monitoring. And Google logs a ton of stuff for you already. So it logs, you know, all errors from your app. It logs all requests and responses. And the really cool thing is that the logs are searchable in the cloud itself and backed by BigQuery. So anything I emit from my logs, and then I want to go search by like particular event ID, I can go in there. There's a bunch of drop downs, so I can say, all right, between these days, how many errors of this type do I have containing string fuck, which is how I display all of my errors. It's a really great way to filter. But again, not something, we used it a lot in the initial phases just because didn't really have a good reason, because it's really easy to attach live debuggers to your code, which you should also always do. But it's great that they provide this. And that kind of goes to my central conclusion about the original thesis of why we used Google Cloud, is because Amazon has a ton of amazing stuff that they do, and it's arguably more mature in an enterprise ecosystem than the Google Cloud, even though I think the individual components in Google Cloud are more reliable and faster. But I think the thing Google does better than Amazon is data infrastructure. So cloud storage or cloud data store is awesome. All the ORMs around it are great. Bigtable is super cool. I think there's something like, I think the minimum table size to be effective in Bigtable is 300 gigabytes. It's a key value store. And then the 99% read-write latency is like 7 milliseconds, which is nuts. I think it's faster than like my PowerBook G4 on like local cache. So, so Google is great at data. Cloud Data Flow is it's like a way awesomer version of Kinesis plus Spark. So stream processing, which I'll come and talk about in a few months, something cool we're building at 22 Acacia, Google is great at. So even though Google has less, if you're building a data-driven app, I think their experience, and I like their developer console more, is better than AWS. But if you just need like a bunch of different components and you're building something really huge, like your Netflix, whatever, you should probably stick with AWS. So, you know, we launched, we didn't get 1 million users, but nothing ever really went down. That was cool. And so it was a great experience. But the thing Google really needs to do is they need to double down on their enterprise investment. They just hired a new VP of work or whatever that encapsulates cloud and all this other stuff. But you can kind of tell that Google's focus hasn't really been on enterprise because developer tools are non-existent. I know 22 Acacia, we're going to roll out Terraform scripts or basic core modules for everything in Google Cloud that hasn't been built, like 90%. So like Cloud Data Flow, BigQuery, and so on. So if you want to use Google Cloud, you're basically stuck with a CLI, a Java SDK, sometimes a Python SDK, and rarely a Go SDK. So you have to roll all your own tools, which is really painful. And Google needs to hire more SDETs, as I used to call them in the Microsoft world, to test things, because some things apparently haven't been tested in a while. So like there were bugs in image resizing that I had to go through Stack Overflow to understand, even really simple things. And there's things which are still kind of broken, like cloud endpoints don't work on managed VMs. Managed VMs are cool, but you know, they're still in beta, and so you can't really rely on a lot of parts of it to work. So you can't port your app to a managed VM yet. Can't access cloud data store reliably through managed VMs. There just needs to be more investment in testing and documentation, and faster iteration. Again, App Engine is on Jetty 6. I know they're trying to like sunset that and move to you know, managed VMs for everything, but it's stuck on Jetty 6. That really ruined my life for a while. And you know, the most important thing is I think they should write Clojure SDKs for absolutely everything, because teams love Clojure and Google wants to be cool. That's it. Any questions? What's that? You're going to have to shout really loud. Yes. Doing what with data streams live? We would love to talk with you about that. This might be an exciting development opportunity to engage with 22 Acacia on. But really, I think Amazon, well, I think both Amazon and Google offer streaming video staging. I know Amazon does a bunch of transcoding and has like a bunch of really cool video tools. I'm less familiar with Google. By the way, Google reps, raise your hand if you're here and do stuff with Google. All right, anybody at Amazon raise their hand? Cool, so talk with those guys. Anybody at any other infrastructure company who cares about scalable systems, raise your hand. All right, well, go talk to anybody who's raised their hand. So yeah, that's all I've got. I've never really worked with streaming video, but the major cloud vendors do offer some cool stuff around that. Okay, I think it, is that what I saw ads on Reddit for? Oh yeah, I saw that. Cool. Other questions? Scalability, distributed systems. Hey. None. I mean, I think with way too much redundancy, our operating costs are like hundreds of dollars a month. It is a little difficult. They do provide a lot of, so the only big question in cost for us was cloud data store, because they bill by like reads and writes and a couple other things. And when you're using an ORM, you have no idea like how many reads and writes are really going on. But they provide a profiling tool that you can basically just load as a servlet, because everything in Java is an object and everything is a servlet. And so it'll tell you like this request has this many reads, that many writes, takes that long. So you can extrapolate and do the math. And they provide calculators for all of that. So it's not intuitive, but the tools exist to help calculate it. Other questions? Sorry, I saw a hand over here. No. As far as, so you're asking, did we have trouble managing versions of the mobile versus API? So we didn't refactor the API per se, but we did version it. I think we had 4 pretty big versions. And so the cool thing is that you can sync your API version to the App Engine module version, and then basically route things in your HTTP header from your client. We'd be like, this is client version 4. Therefore, hey Google, route anything with this HTTP header to this version of the module. And then over time, we would spin down instances of the old version, and as less and less people use them. So it was really painless. It was very cool because in my past, like back in 2009, deploying versions APIs gradually was a nightmare. Hey. Yes. No. Yeah, that was actually another big thing that I should have put on my list is, well, it kind of goes in with the no ops, is I didn't want to use any ops tools. So to deploy my entire stack, I literally type like mvn deploy, and then it just goes and does it, which is really cool. Now with 22 Acacia, we're doing a lot of we're rolling out a product for our clients that's basically a collaborative stream processing environment. And so that has a lot of Terraform behind it to bring up like sources and sync data flow jobs and so on. So that's cool.
You were talking a little bit about using BigQuery for analytics scenarios.
Yes.
Are those queries being initiated with the mobile app itself, or are they all back in?
No, it's just, yeah, it's just back-end like business decision support. You have to speak up. Too many metal concerts. Deaf. We do have a chat client, which I didn't really talk about because it uses Layer. That uses WebSockets, but that doesn't go through, doesn't really go through that's infrastructure. So we're just straight up HTTPS. Looked at doing HTTP2 for some more advanced stuff, but we're still about a year, well, App Engine won't support it because it's Jetty 6. And I think you got to be on Jetty 9 to support HTTP2, and nothing really supports it yet. That's really good for batch requests and a few other things. But yeah, we're just straight up HTTP. We use like the most boring technology decisions possible because I hate 2 a.m. phone calls. Yeah, we do a lot of aggressive caching on the client. And one of the things we focus on is kind of a life decision that there should be tools to make easier. But there's APIs that make sense for the back-end developer, and then there's APIs that make sense for the front-end developer, and they're usually wildly different. Like on the back-end, you know, I have something that's like add item to my wardrobe, and it takes, you know, a HTTP body, and then there's like get item from wardrobe, And my front-end developer is like, well, when we're disposing, or when we're displaying like a picture, there's like a profile photo, there is a, there's the item photo, there's like the tags, there's like profile data. So there's like 4 API requests to render one thing. And so we kind of ended up making a one-off shadow API that didn't have the nice composable interface, but was like, get this photo, and or like get this timeline object, and then it batched all these requests and returned them. So it's kind of weird. I think in Clojure there's this thing called, I forget what it's called, something like, is it prismatic graph? But there's a way to basically define dependencies between HTTP requests, and we ended up writing something like that for Objective-C, where it could say, this particular rendering requires this part of a dependency graph, like we need this photo, and we need this get image call, we need this get profile call, and then only render certain things when their objects exist. So there's like this whole thing of dependency management between HTTP calls that big opportunity to build something around. It's kind of a rant. Say what? Oh, I knew you were going to ask that, Jeremy. I like Clojure because I do a lot of stuff with data. And in Java, 90% of my code is written by my IDE to convert one type to another. And God help me if you have nested maps that need to make 15 nested for loops. So in Clojure, I can be super lazy and be like, this is a map. This function is applied to the map. I'm going to go drink now. That being said, I have not figured out how to maintain a large Clojure code base. So a pro tip is do use typed Clojure if possible, so you can infer something about how anything works. But Clojure is great for projects of like 1 to 5 people, and I've found that I can do work about 5 times faster in Clojure than Java if it's like data-y stuff. That's my Clojure rant. Other questions? All right, last question. I looked at Scala 5 years ago, never looked back. I was trying to debug something in Scala, and I just remember looking through the sort in this like quasi-Scala, and then there's another layer of less Scala-y, but kind of Java-y, then there's like another layer of mostly Java with some pattern matching, and then there's like finally the Java code, which is completely incomprehensible in comparison to how the Scala works. So as much as I like the idea of like a weird Haskell for lazy people on the JVM, I just couldn't wrap my brain around it. That being said, if there is ever a Haskell in the JVM, please do tell me about it. All right, I'm going to wrap it up. Thank you so much. Ping me or Nick or Pat if you want to build distributed systems. Google AWS people, raise your hand again. All right, ask them questions that don't involve giving us money, and have an awesome night. Next up is Zulily, and however Nick pronounces Kubernetes. Yeah, that. Oh, my last. Yeah. I've got a mini display port to HDMI. Do you have HDMI? All right.
I'm going to try to go to the side.
Ah. That was around my neck the whole time, huh? Cool.
TVs, I guess. Steve, I'm going to mic you up while you're. Okay. Oh, sorry about that. Yeah. Thanks. You're also going to talk into this, so this will take care of everything else. Oh, okay. Okay. Where's Dylan? It worked the first time. is what you're seeing. Okay, this is what's going up live.
Okay.
Whenever this GoPro here.
All right. Okay. So no Hangout thing on here?
No.
Okay.
Cool.
All right. All right. Should I get started then? Are we all excited about Kubernetes tonight? I hope. All right. I'm always excited about Kubernetes. You should ask my wife. Anyway. Let's see. Let me get my bearings here. I didn't think I'd be standing in front of the TVs, but I think I kind of have to. So I'm going to just kind of do a really quick kind of intro slide deck and then just bore you to tears with command line demo. It's going to be all console. And I really hope the network works. Actually, let me just triple check that real quick. I have no reason to believe that it'll fail. Okay, so I'm going to talk a little bit about how we actually use Kubernetes here at Zulily on production workloads, production cluster for a real purpose that helps generate money. We don't use it, to be clear, we don't use it broadly across all of Zulily. I've had a few questions about that already. My team who works mostly in personalization, we use it primarily to deploy our workloads to the Google Cloud, but there's other things happening here as well. So let's go. I already said what this stuff is. You're going to see a lot of weird, like, garbly stuff in the output, though. So since I am actually going to be demoing on our live production cluster, I don't really want you guys to see, like, our code names and, like, certain things. So I'm going to obfuscate a lot of the output. If you see something you shouldn't see, then try to forget it. I'm going to tell you up front kind of what I want you to take away from this talk. Or I guess a couple of the things you're free to take as much away as you want. Primarily, I think one thing that we've greatly benefited from by using Kubernetes to run our workloads is we also get access to the Kubernetes API. It's not just for the kubelet that runs on all your nodes. It's not for the controllers, the schedulers, and all that kind of stuff. You can use it for your own purposes as well. And I'll kind of highlight some of those cases. And this isn't necessarily exclusive to Kubernetes, but once you're deploying your workloads with Kubernetes on a cluster, your compute resources, like CPU and memory, become very highly fungible. You don't really care where they come from. They can kind of come from anywhere, just as long as you get something. And those are my slides. Let's do this. Okay. All right. Oh yeah, we'll go back to the browser real quick, actually. Don't worry, I knew that would happen. So just some kind of high-level metrics from our cluster. I took this before the meetup started. I didn't want to rely on the network to get to these things. And you can't read any of the letters, that's totally fine. At the top, this is the request latency of our application. All of these things go back for a week. I thought about only going back a day so you wouldn't see this, but I have no shame, that's fine. bad stuff happens. The second one is a chart. The green stuff is successful requests, and the yellow one is failed requests. On this, we are doing, and these are a minute, requests per minute, I believe, 100,000 requests per minute at peak here, and it's on a logarithmic scale. So this is 10 times fewer. We have a pretty bursty workload. And then the yellow crap at the bottom is failures. So we look for as much distance between those as possible. So that's just kind of our workload. We're basically services running in the cluster. They're mostly APIs, HTTP APIs, things like that. We try to do high throughput with a relatively low infrastructure footprint. We try to keep the latency low. Those are kind of our main scaling requirements. The third thing is the number of containers running in our cluster. And there's a couple interesting things about this. One is that this line here is at about 500. I'll get to the size. Our cluster is really only 25 nodes, so we're running 500 containers on 25 nodes at the moment. But the other interesting thing to me, and to you, because I'm telling you it is these bumps up here. These are automated processes that we have in place that are deploying pods into our cluster for us. Not everything that we deploy is done with a tool or by hand. We actually have kind of built pod deployment into some of the areas of our application. And so we go from 500 to roughly 600 containers in bursts. And the other thing that I kind of geeked out on, and I'm gonna make you see this, is the bottom one here. It's in the, I don't know if you can see it in the back. I really hope you can. You don't have to really get too much out of it. I'm just going to point out some interesting things. This is a chart of the request rate on the Kubernetes API server, the master. And each line is a different user agent, so to speak. And so what's interesting is this little light blue guy. This is, what is it? This is something that runs on the master. I forget what it is, but it's going along. And then right here on the 4th of December, sometime between 8 and 4 o'clock p.m., the color has changed. That's because the version changed. This is something that Google did for us. We're running Kubernetes on Container Engine, so you don't have to run the master. This was the point in time where they upgraded the master server for us. So that's where that line changes. You definitely can't see this, but another cool thing is that there are these purple humps down here at the bottom, and that those basically happen between like 9 and 4, and that's actually us using kube control. And then the other interesting thing here is Monday, this tan line kind of descends down gradually, and this light blue line comes up to replace it. These are the kubelets on the nodes, and this is when we did a automated rollout of the upgraded Kubernetes. all these different processes. So what we did instead is strip out the queue, get rid of the queue entirely, and convert all of those ingestion workers into processes that would just do one thing. And then when we got an ingestion request, we would just create a pod in the cluster to ingest one artifact. That was analogous before in the old design of one message propagating over a queue to somewhere, maybe nowhere sometime. But now, when we create the pod in the cluster, we can monitor its state. We can see if it fails. If it fails, we can restart it. And the whole process got a lot simpler. And I was just going to kind of prove that, I guess, by showing some JSON. And this is the replication controller for that scheduler, where we just configure as a property what is the actual image to use for ingestion. Everything else is kind of baked into it. But we're kind of also reinventing the wheel here, too. This is kind of something that is meant to be put like a feature of Kubernetes itself. Here's pods that are running ingestions currently right now. There's one that started 8 minutes ago. There's one started 16 seconds ago. One that's been running for 20 minutes. So good news, Kubernetes 1.1 has jobs. And that's what this sounds a lot like. So we can't wait to move to that as well. Probably simplify even more and delete more code, which is always a good thing. The other really nice thing about Kubernetes is that, at least for us as Go programmers, you can stomach the number of dependencies that come along with it. The API is fairly easy to use. I wrote this this morning. It looks better with the font in old man style like this. It's my favorite. But anyway, this is just really simple interaction with the Kubernetes API. Connect to Kubernetes, get a service lister, get an endpoint getter. Those are interfaces I invented. But these things are coming from the Kubernetes API that I'm importing. And then listing services is as easy as providing a query to the list function, and then you can range over them and get endpoints. Here I'm just counting how many endpoints the service has. Connecting to Kubernetes is also quite simple. Here we first assume that our code is running inside of a cluster, and there's a method to get Kubernetes configuration if you're running inside of a Kubernetes cluster. So you call that first. If you don't have any errors, you return it. Otherwise, what we do is we do what kubectl does, which is look for config files in the current user's home directory or somewhere therein, and it returns that. So I can run this as myself, or I can deploy this code to production and have it run in the production cluster. So let's run it. These are services in our cluster and how many endpoints they have. So that was, kind of the gist of the code that we had to write for that reverse proxy. Here I kind of reiterate a point I already made, so I'm just going to skip over that. And then to kind of sum up, I think the last point I want to make is one about just resource fungibility and kind of things that are fun to do once you have a container scheduler doing your work for you. What is this doing? I forget. Oh, yeah, this is getting the name of one of our API server pods. And this is taking that name and passing it to kubectl delete. So now the pod's gone. Process is being killed, the pod is being cleaned up, the image maybe is being removed. I don't know if that happens anymore. But it's gone. It's being removed from the list of endpoints for the service, and it doesn't exist anymore. But fortunately, we have a replication controller in the cluster, and it's there, and its sole purpose is to make sure that we have the proper number of API servers running. So I'm going to get events from kubectl. go to the bottom. I'm going to highlight portions of this because it's impossible to read. But if we scroll up a little bit, oh, and then I accidentally scroll. There's the pod getting killed 29 seconds ago, right around the top there. And then shortly thereafter, the scheduler schedules a new one, and it's running again. So to kind of wrap up, I think the final point I want to make too is when you have something like Kubernetes on top of your compute infrastructure, the kind of old concepts of dev and prod infrastructure just totally go away. Dev, test, prod, there are designations for the software you're writing. It's more an indication of the state that it's in. It has nothing to do with the instances or the VMs or machines you're deploying to. The machines just provide ubiquitous compute and memory resources. So for example, this whole demo, I've been running it on my laptop, but why don't I run that in the production cluster? I put it in a Docker container. I'm going to kube control run it, capture input, call it SeaScale, specify the image, tell it to never restart because that would be stupid. And I'm just going to rerun this last portion of the demo. And this is the part that I really hope works. Hey, there we go. Any CPU is good CPU. We're going to get pods again. Hey, that's the name of one of our API server pods. So why don't we delete it? All right, I deleted it. This part didn't work when I tested it. We'll see. Oh yeah, it totally works. So killing the pod, that still worked as well. Keep in mind that dev, test, prod, that's just a designation for the process you're running. It has nothing to do with your infrastructure. For example, this demo, fortunately this fails because the pod name already exists, so it won't create a second one. And that's all I have, the end, and then we come back to my laptop, the end, and that's actually the end. Thank you. Questions? Yeah. They're all distinct services. Not all of them have actual endpoints. I kind of cheated. Most of them do. But they're all varying different services, like some examples. Like we've taken our API and broken it down into many different smaller executables, and so each one of those gets its own service. But again, I think the other point I try to make too is the services are mostly internal to the cluster. These aren't things that we're always necessarily exposing outside. But yeah, they kind of add up. They're super powerful. Services are great.
So you guys are running on Google Cloud, so Kubernetes might be a natural fit. But do you guys evaluate any other alternatives in that space, like Helios, Marathon, Zoom?
No. So we landed on Kubernetes a while back because we were drinking the Docker Kool-Aid pretty good, and Kubernetes was really interesting because we actually met up with one of the founders at a local meetup for CoreOS. And honestly, I think a majority, other than me being a notorious Google fanboy, I'll say it, the majority of the reason was how immediately engaging the Kubernetes developers were with us in understanding our potential use case, the problems we were having with running Docker in production without something like Kubernetes. And then also I think the other aspect to it too was things like Mesos just seemed like either insane overkill for the scale of our infrastructure or just too hard to kind of wrap my head around at the time. So Kubernetes was pretty straightforward from that perspective. So the question was what specific Docker issues Kubernetes helped us work around. And for us, we were coming from a method of deployment where we had servers dedicated to specific roles, and we were deploying processes to those. And Docker really didn't give us much in that respect. We already had the hosts prepared the way we wanted them. We didn't get a lot of benefits out of that. And really all it did was kind of obscure operators from where the actual processes were, where their files were, all that other kind of stuff. And also when you're running containers off of images on a production machine, just the simple act of stopping and restarting something can give you a lot of false starts. And I think we had a lot of issues there. So we knew there was an opportunity to automate a lot of that. And I think that's why we started looking. We deployed Docker containers into production, and within weeks, we had reverted back to older ways of doing things, just because of thorny issues in operating them, people coming up to speed on Docker and all that kind of stuff. Not that Kubernetes isn't something to come up to speed on, but. So did we ever create a load balancer but never get a public IP? No, I don't think so. But we've only ever created a couple, so, you know. So we didn't try to create one yesterday, so we didn't have that problem. I don't know if you heard about that. Yeah.
Can you talk a little about adoption costs, like what kind of a project it was to get entire team on board, trained, and so forth?
Sure. I might not be the best example of how to do this. This project that we did and what this cluster is doing was, for the most part, a greenfield project internally, and was being built by a small team of 3 people, 2 of which have become traders and left. It's just me now. Anyway, so I think the key for us was we were committed to moving towards container-based deployments and that kind of thing. And so for us, we were learning as much about Docker as we were about Kubernetes at the time. And I think that was pretty helpful for us. I can't exactly explain why, but it felt that way.
Can you talk a little bit more about the types of services you're running, why they're good to Kubernetes, why you said maybe you were just looking at certain kinds of volume like that. If you're storing anything.
Yeah, most of our services are stateless. I think that's one thing you're kind of getting at. In our project, we're storing and retrieving a lot of data in the Google Cloud Bigtable. But we have a lot of like large scale, kind of long time scale bulk batch processing that we want to do as well. So I think for us, Kubernetes is good because we don't want to get into the details of provisioning hardware or understanding where things are being deployed to and run. We wanted to be able to mix processes that have to serve low latency API calls with ones that are being started up to do bulk data ingestion. And we want to be able to get the process isolation and deploy multiple containers on a single host, but we just didn't want to own that problem. So for us, that was great. It was a great fit for that. Yeah, they're mostly Go programs. We have some Java stuff up there too. A couple of slide decks that are using Reveal.js and that uses like, I don't know, Node or something, who knows. But for the most part, the stuff we're developing is Go. You don't need to use Go to use Kubernetes. We got to go drink beer, everybody. So yeah, I'll see you there. Thank you. I don't know how to.
All right, everybody, it is beautiful time. Beautiful, wonderful time happening time one. We're going to have it one. Where is it?
That way.
It's that. No, I thought that was the ocean.
Yeah, it's on the way to the ocean.
Okay.
It's on the waterfront.